Okay, here's numbers 1 through 17 of your final exam review. Let me see here. Why is that showing up? Alright, so this one is using the Venn diagram below. Which statement below is correct? Well, it says a rectangle is a square. If you look over here, all the rectangles aren't in the square, so that's not true. A parallelogram has all the properties of a rhombus. Well, all the parallelograms aren't inside the rhombus, so that's not true. A quadrilateral is a rectangle. Well, all the quadrilaterals aren't inside the rectangle, so that's not true. A square is a rhombus. If you look here, all of the squares fall inside the rhombus circle, so that's our correct answer choice. Number 2 is in trapezoid WXYZ. A is the midpoint. So these are the same. And these are the same. B is the midpoint. What is the length of WX? So that makes this a mid-segment. And our mid-segment formula is that the mid-segment is equal to base 1 plus base 2 divided by 2. So this I told you to change to 18. And this is base 1, this is base 2, and this is my mid-segment. So if I plug in what I know, my mid-segment is 12, base 1 is 18, plus base 2, we don't know what that is, divided by 2. So we cross multiply, 2 times 12 is 24, equals 18 plus base 2, which I'm going to call x. So then I draw my line, I subtract 18 from both sides, and I get x equals 6 centimeters. For quadrilaterals ABCD and FGHJ, angle A is congruent to angle F. So here we have A congruent to F, B is congruent to G, and C is congruent to H, which means that D and J have to be congruent. So if we look here, this one doesn't have D and J, this one doesn't have D and J. So here angle D is congruent to angle J because they are congruent quadrilaterals. Angle, angle, angle does not prove congruence, it proves similarity. So this one is not correct. This one is the correct choice because it says they are similar quadrilaterals. Which of the following sets of vertices do not represent a parallelogram? So all I'm going to do is plot these points. So if I look at A, that's 0, 5, so there's 1 there. Then there's 6, 10, so here's 6, 10. And then 7, 6, so here's 7, 6. And then 1, 3. So there's, where's 0, 5 go? It disappeared on me. Alright, so there are my 4 points. Now what I need to do is make sure, wait a minute. Oh wait, that last one should be 1, 1. So instead of 1, 3, it's 1, 1. I looked at it wrong. So we'll delete this one. Eraser will erase this one. And we'll put the other one back. Now what you need to make sure is that they're the same slope on each side. So here I go up 1, 2, 3, 4 and over 1. Here I go up 1, 2, 3, 4 and over 1. So I go up 4 and over 1, and then here I go to the right 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4, 5. To the right 6, 1, 2, 3, 4, 5, 6, and up 5. So we do that with all of them, and we find out that this is the one that does not form a parallelogram. Given the following sets of Pythagorean triples, what geometric formula proves that these are Pythagorean triples? Well, that's the Pythagorean theorem, which is a squared plus b squared equals c squared. The diagram below shows quadrilateral ABCD. Determine the value of x. Well, all the angles of a quadrilateral add up to 360. So what we have to do here is add these all up together. So we get 3x plus 5 plus 7x plus 10 plus 75 plus 90 equals 360. And when we combine like terms, we get 10x plus 180 equals 360. Subtract 180 from each side, and we get 10x equals 180. Divide by 10, x equals 18. Now remember, if you need to slow this down and rewatch it and follow the steps, do that. Rewind it. That's a privilege that you have because it's on video. Number 7, which of the following could not be the result of a cross-sectional slice? That is a parabola. You cannot make a cross-sectional slice of a parabola. Trapezoid ABCD has 3 of its vertices located at A, which is at 2, 4, B is at 6, -4, and C is at 1, -6. AB and CD are legs, so that's a leg, and wherever D happens to be somewhere over here, that's a leg. So that means that this is the base. That means my mid segment is somewhere in here, in between my 2 bases, and it's parallel to this base. It's kind of like if you go back and look at number 2. The 2 bases are parallel to that mid segment. And parallel lines have same slopes. So if I can find the slope of that base right here, then I know that it has the same slope as this mid segment. So to find the slope, I do rise over run. So I go up 1, 2. So my rise is 2. And then my run is 1, 2, 3, 4, 5. So 2 over 5. They're both positive, so my slope of my base and my mid segment is 2 over 5. Rectangle ABCD is shown on the coordinate grid below, which is the closest to the length of the diagonal AC. So we're trying to find this diagonal right here. So I know this side is 1, 2, 3, 4 units. This is 1, 2, 3, 4, 5, 6, 7 units. This is a right triangle, so I can use the Pythagorean theorem, which is a squared plus b squared equals c squared, where the longest side is always c. So I get 7 squared plus 4 squared equals c squared. 7 squared is 49. 4 squared is 16. 49 plus 16 is 65 equals c squared. Now I take the square root of both sides and I get c equals 8.06. Points A, B, C, and D are the vertices of a square. Points E and F are the centers of 2 congruent semicircles that are tangent to each other at point G. Which is the value closest to the area of the shaded region? So well, first I need to find the area of my square, and then I need to subtract the area of my 2 semicircles, which make 1 circle, and then I'll be left with this shaded region. So the area of my square, this side is 1, 2, 3, 4, 5, 6 units, and this side is 6 units because it's a square. The area of a square is base times height. So 6 times 6 equals 36. That's the area of my square. Now I need to subtract the area of my circle. So the radius of my circle is half of one side, which is 3. So that is pi times r squared is the formula for area of a circle. So pi times 3 squared. And pi times 3 squared is 28.27. And when we subtract 36 minus 28.27, we're left with 7.73.